Hi and welcome everyone. My name is Sandeep. Welcome to another session of BGP. This BGP session will be more exciting than my previous videos because we are going to configure a lot of things in this BGP. So we are going to discuss today about load sharing in BGP. It's a dual homed to a single ISP, which means that we have got two routers and we are at our internal network and we have a single service provider with two routers. Okay, so we are going to pair with our ISP and then we are going to accomplish some task. Let me quickly take a screenshot of this so I can explain it in more detail. Okay, so we have got this topology. So what we are going to achieve here is, okay, so you would have seen that all the internet service provider are usually advertising a default route to to your local network. So we are going to do the same thing. The first task we see here is that Autonomous System 200 is going to advertise a default route to router 1 and to router 2. So we are receiving the default route now. So if any of the users from our LAN side here, if they want to reach to the internet, they are going to use this default route. So now we are receiving the default route from both the sides. We will apply some policies and we will make a load balancing possible in the BGP. So how we are going to accomplish that? Let's see. So let's understand our outbound policy. So let's say what we need to achieve here. R1 should use R1 R3 link for internet. So for example, if this computer is sitting here and any traffic is coming to router 1, he should use this link to access the internet. If this link fails, if this link fails, the traffic should be diverted to router 2. Let's say if this link is fails and the packets are coming to router 1, the router 1 should send the packet back to router 2 and then the user should access the internet. Similarly, we are going to apply for router 2. Any packets from this host coming to router 2 should always pass through router 2 to router 4. So we should always access the internet from this router. Suppose this link is failed or if there are any issues with the ISP, then this traffic should pass via IBGP and to the router 1 and it should, the internet should be accessible to these users. This is about the outgoing policy. How about the incoming policy? So let's understand this. Traffic from internet destined to this primary subnet should come from R3, R1. So let's say we have some server sitting here. If he wants to access any of my network, let's say I'm advertising this 11.0.0 network, and if they want to access this 11.0.0.0 network, we are going to define in such a way that the traffic should always come via this this path, router 3 to router 1, this here. If you want to see that the traffic from destined to this second network, that is 12 network, okay, if anyone trying to access from internet this network, so the traffic should always come via the second link in this direction. Okay, I hope this is clear so far. If one of the links fails, let's say if this link fails, the traffic should automatically come via this link, and if this link fails, the traffic should automatically go via this link. So this is our requirements, and I've seen that most of the network setups will be in this way. Okay, so let's see how we are going to configure this and what is our how we can crack this and how we will configure. So let's see our strategy first. Before we configure anything, we just need to think about how we will do it. So here is my strategy plan for this task. Okay, so the first thing in my network what I will do is I will configure a primary and secondary IP addresses on LAN side of the interface. So here I am going to configure primary and secondary IP addresses. In real network it would you would have two different subnets. So I will do on this interface, I will configure the primary IP address as 11 and 12 as my secondary IP address. Okay, this is used for testing purpose, right? So okay, this is done. Second thing, advertising both networks to ISP in BGP. Very simple. We are going to advertise these two networks to the ISP network. Okay, so we will advertise via R1 as well as R2. So we will have a eBGP between router 1 and router 3. Similarly, we will have eBGP between router 2 and router 4. This is clear. Now the third step is iBGP between R1 and R2. So I will have a iBGP session between R1 and R2. I will configure next hop self because this is eBGP will process it that way. So we need to configure the next hop self here on the iBGP. Okay, then we will configure maximum path because we may learn this route from multiple paths because we have two paths and the BGP by default will select only one best path. So to have two paths in our routing table, we should use a maximum path. Okay, so I will configure maximum path here in the BGP process. Then we need to focus on these policies, outbound policy and inbound policy. So to accomplish this, I will do one thing. I will configure two standard access lists to permit a network 11 and 12. So I will configure one ACC and I will tell that you should permit this 11 network, and there I will configure one more ACL and I will tell that okay, you should permit this 12 network. Once we do that, I will configure a route map. Okay, so the route map will be applied to the eBGP neighbor on this as well as on this network. Okay, so in this what I will do is I need to prefer. So the first task what I see is I should, for the inbound traffic, I need to set the autonomous system AS path to the higher level. So in this case we are going to use the AS path metric so that our traffic should come via the secondary link, which means that let's say these users, okay, they want to access this 12 network or 11 network. Okay, so these users wants to access the 11 network, and what we are saying that in our this policy, these users should always use this link. Okay, so we will accomplish this by configuring the higher AS path numbers. So I will prepend more AS path here so that this network will be preferred. So I will prepend more AS numbers for 12 network. So it always use 12 network via this path and 11 network via this path. This accomplishes our task. Okay, so I think that's the strategy and plan, and I hope we should start doing the configurations. The verification will come at the later point of time. How we are going to verify this? There are a lot of verification steps we need to follow. So let's quickly jump onto this. To understand this better, I have already configured the IP addresses here on my routers. However, I have not done any configurations about the BGP. So let's not spend much time. Let's start configuring the BGP. Okay, so I am on a router 1. Let me quickly move this here so that I can see what's happening in the background. Okay, so I am on a router 1 here. Let me configure router BGP 100, and let me just quickly bring up this. I will configure eBGP neighbor first with router 3. The commands are straightforward: neighbor 10.1.13.3, remote autonomous system is 200. Similarly, I will form a iBGP neighbor here, neighbor. Okay, so IBGP neighbor, I will form. How would I form the IBGP neighbor? Okay, what are the IP addresses? Let me quickly verify the IP addresses. Do show IP interface brief. I have one of the interfaces admin down, so let me bring that interface up. No shut. Okay, so I'll form a IBGP with 11.0.0.2 neighbor. Okay, router BGP 100 neighbor 11.0.0.2 remote autonomous system is going to be the same because this is IBGP neighbor, right? Okay, then we will configure maximum path 4. We should be good with 2, but let's configure it as 3. Then what else we could do? Neighbor 11.0.0.2 next hop self. Okay, then let's do the similar configurations on router 2. Router BGP 100 neighbor. Let me configure the IBGP first. Neighbor 11.0.0.1 next hop self. Then what else I am going to do is okay, neighbor my EBGP pair 10.1.24 10.1.24.24.4 remote autonomous system is going to be 200, and that's it. I think we should be good now. Show IPBGP summary. I'm not forming any neighborship yet. Ping 11.0.0.1. Let me see if the ping is working between router 2 and router 1, which is not working. That is not a good sign. Show IP interface brief. Okay, this interface looks disabled. Interface FA0/2 no shut 0/1 no shut. Show IP interface brief. Let's verify this interface is up now. So I should form a IBGP neighbor here. Okay, let's give some time for BGP to come up. I'm jumping onto the router 3, which is this router. Router 3, I will form a EBGP with this router 1. Router BGP 200 neighbor, what's that, 10.1.13.1 remote autonomous system is 100, and I will form a IBGP neighbor with 10. What will be my IBGP neighbor here? Is it going to be this? Okay, 200 I can configure with the 200 IP address. So let's go ahead and see if I have already configured the BGP. Show IP interface brief. Do show IP interface brief. Do I have this? Okay, I have this, but the interface is down. So /1 no shut. Router BGP 200 neighbor 200.0.0.4 remote autonomous system is going to be 200. So this is done. We will come back and verify the BGP neighbors. Show IP interface brief. Exclude unassigned. Conf term router BGP 200 neighbor. Okay, so my first neighbor is 10.1.10.1. 24.2, 10.1.24.2, remote autonomous system is 100, neighbor 200.0.0.3, remote autonomous system will be 200. This is iBGP and this is eBGP. Okay, so am I missing anything? Okay, for the iBGP neighbors, let's go ahead and do update source next off self. Similarly for router 3, router BGP 200, neighbor 200.0.0.4, next hop self, maximum path 3. Let's configure here as well maximum path 3, and we should be good. Show IP BGP summary. This is still not active. This is still active. So let's ping this IP address, ping 10.1.24.2. This IP address is not reachable between router 4 and router 2. So let's go ahead and verify. Okay, so it looks like interface FA 0/0. I have configured 24.1 as IP address, wherein in the BGP I have configured 24.2. So let me change this IP address. IP address is going to be 24.2, and let me ping 10.1.24.4. See, the BGP has come up. Okay, let's verify. Show IP BGP summary. I should see two BGP neighbors on router 2. I'm on router 2. So I have BGP neighbor with 24.4, which is this router 4, and also I have BGP neighbor with router 1, which is this. Similarly, I will verify the same thing here. Show IP BGP summary, and I see I have two neighbors which are up with router 3 and with router 2. Okay, let's verify the same here. Show IP BGP summary. I should see two neighbors here, and I should see two neighbors here. Okay, which looks good. So far, what we have done is I have formed a IBGP neighbor between these two, IBGP neighbor between these two. Then I have eBGP neighbor here. Then I have eBGP neighbor here. Okay, so let me take this screenshot again, and we will start working. Okay. Okay. All right. So far we have done IBGP neighborship. Now let's go ahead and see what is our strategy. Okay, this is our strategy. Primary, secondary IP address we have configured. This is done. Advertise both network to ISP in BGP. This we have not done. So let's go ahead and do that. Let's advertise these two network into BGP. So I am going to jump on router 1. Term router BGP 100 network 11.0.0.0 mask 255.255.255.0. Similarly, I will update 0 mask 255. Okay, and I'll do the same thing here on router 2. Conf T router BGP 100, and what I'll do is I'll just take this here and I'll paste it here. Similarly, I'll take this one and I'll paste it here. Okay, so what we have done is we are advertising these two routes now to router 3 and router 4. Let's quickly verify if I have received this route. Show IP BGP summary again. Okay, so I'm seeing the two prefixes received here. Okay, so let me just, or I'll do show IP route. You'll see the routes. Okay, so 11 is here, learn from BGP, and 12 is here, learn from BGP. Similarly, I will verify show IP route. You could see that the two networks what we have advertised are already here on the router 3 and router 4. So let's go back to our strategy, and we have done with this. We have step number 1 is done, step number 2 is done, step number 3 is what IBGP between router 1 and router 2, which we have already done. Next hop self we have configured, and maximum path we have configured. This is done. Step 3 is done. So step 4 is my step 4, and this is step 5. So in the step 4, what I will do is I will configure the access list, standard ACL, and I will permit this. So let's go ahead and do that. On router 1, access list, a simple standard access list. Access list 1 permit 11.0.0.0. I need to specify the mask here, and what I'll do is I'll put a log access list 2, and I will permit this. Okay, so I've configured two access lists to show IP. Similarly, I need to configure the two ACLs in router 2. Okay, so I'll take this T. Similarly, I'll take this second one, and I will add it on the router 2. So far we are good, right? Okay, there's a lot of work here. So we have configured two access lists, 11 and 12. I mean the access list is 1 and 2, and I have added these networks. The next thing is that the important step is that we need to configure the route map, and we need to call that route map into the eBGP neighbors. So what we will do is we will configure a route map with the name R1 R3. Okay, we will call the name with R1 R3. Let's understand this a bit. I'm going to configure a route map with the name R1 R3, R1 R3, and I will call the access list number 2. I will call the ACL number 2. This is my ACL2. This is my ACL2, and this is my ACL1. ACL1. So what I want to do is I want to set a additional AS path prepend to this network. So what I will do is I will call this ACL2, and I will set the AS prepend. Okay, so let's go ahead and do that. On router 1, I will configure do show access list. Just quickly verify the access list that we have correct entries. Okay, we are having route map R1 R3. I will name it as R1 R3 only for ease of understanding. Permit 10. Then what I will do is I will call the ACL match IP address, match IP address. Then what is the access list number? Access list number is 2. Then what I will do is I will set the AS path prepend. I will prepend the AS path with 100, 100, 100, 100. Let's say 4 times. 4, or let's do it 5 times. Okay, I have done this prepending of AS path for this particular route map. Now what I will do is I will configure one more route map entry with permit 20, and I will call the second ACL so that the traffic to second I mean the traffic should not block and it should still pass. Match IP address 2. So what have we done? Okay, so we are permitting it again R1 R3 and we are calling the access list instead of 2. This time it should be access list 1. So let's quickly verify our route map. Show route map. So you could see that our first sequence number shows that access list 2. So access list 2 is nothing but 12,000 and I'm prepending with AS path. Okay, 100, 100, 100. So that what is going to happen that whenever some users from this trying to access this 11 network, okay, the 11 network will pass over this link because the AS path prepending will be less here. For 12 network, it will be saying that AS path is 100, 100, 100, 100, and it will think that this is the least path. So let's do that the similar steps on router 2, and we will verify that once we are done. Okay, so I will be back on router 2. Route map I will configure. So this time I will give name as router 2 to router 4. I'll give permit 10, permit 10, match IP address. This time what I need to do is on the router 2 I need to prepend this 11 network so that always 12 network should come via this link and 11 network should go via the other link. So what I will do is I will configure match IP address 1, set AS path prepend 100, 100, 100, 100, 100. Okay, and what I will do is this is done. Exit. I'll do a second entry, a second route map entry, and I will call the second ACL match IP address 2. Okay, so we are done with the route map configurations. Show route map. You could see that I'm doing a ACL. I'm calling ACL 1. Okay, and I'm prepending it. And the second is permit statement. I'm calling the access list 2. Okay, I hope this you are following and it is clear so far. Now let's go ahead and start applying it. Okay, so the first I will come back to router 1 and I will apply this route map for this neighbor, and we will be applying it in out direction because we are influencing the incoming traffic. We need to apply it in out direction. If you want to do any outbound traffic, then you need to apply it in inbound direction. It's exactly the opposite way. For the inbound traffic, you need to apply it in out direction. So let's go ahead and do it in the out direction. Router 1. Okay, so show running section BGP I will do. Let's see what is my neighbor. It should be 10.1.13.3. Okay. Conf t router BGP 100 neighbor 10.1.13.3, and then I will call the route map. The route map name is R1 R3, and as I said it is going to be outbound direction. Similarly on the router 2, show running section BGP, you are going to verify that conf t router BGP 100, you will put the route map for the eBGP neighbor, which is this one. And what I will do here, okay, route map name is R2 R4, and it will be out direction. Okay, so far we are good with our configurations. So let's, I think one more piece of it we are missing, that we are not advertising this 200 network into the BGP here. So let's go ahead and do that advertisement of 200 network in the BGP, so that we should receive that 200 network here, and then I think then that's it. We should be good to proceed with the testing. Conf t router BGP 200 network 200.0.0.0 mask 255.255.255.0. Similarly, get onto the router 4 conf t router BGP 200 network 200.0.0.0 mask 255.255.255.0, and let's quickly verify what is the routes we are seeing here. You could see that the ACL is logging here. List 2, access list 2 is permitted. Okay, so let's do our quick check. Show IP route first, and we should see that 200 network is learnt here. Similarly, on the router 2, show IP route, we should see 200 network is learnt here. Okay, so now the verification part. The strategy for our verification is on the router 2, we need to see show IP route and show IP BGP. So we have done show IP route here, and you could see that this 200 network is coming from router R1, R3. This is our router 1, router 3. So this is what we wanted. R1 should use R1, R3 link for internet. Okay, there's one more piece missing in this, that we said that this is the internet, but we are not advertising any default route. So we could advertise a default route as well from here. So let's do that on the router 3. Let me jump onto the router 3. So how are we going to advertise a default route? The command is, let's do quickly verify how, what is section BGP. Okay, router BGP 200 neighbor 10.1.13.1, and the command will be default originate. Okay, so default originate is going to advertise a default route. Let's quickly verify if you want to. I should see a default route here. Okay, you could see that the default route has come here in the BGP from router 3. Similarly, on the router 4, I'm going to do the same step, show running section BGP conf t router BGP 200, and what is my network? Okay, what is my neighbor? It's this one, default originate, and this, and we should see what we did is we advertise a default route from this. Similarly, we advertise a default route from this. So now we verified on router 1 that we have a 0000 network, and on router 2 we are going to verify the same. Router 2, we will verify that we have a default route. See, before we advertise or before we add the command default originate, you don't see a default route with 000. Now when you do that, you could see that the default route has come. Okay, so in our task, the first thing was what R1 should use R1 R3 link for internet. So we should, when I execute show IP route here, I should always learn the route from R1 R3 link, that is 10.1.13.x. Okay, so let's verify this first part. Let's verify the first part of it. Router 1, show IP BGP you could do. Okay, when you do show IP BGP, you could see that a default route has come from, Okay, this 200 network has come from 10.1.13.3, and also the default route has come from 10.1.13.3, which means that all the routes are coming from router 3. This is what we wanted, right? R1 should use R1 R3 link for internet. If you want to trace it from here, and if the packet is going to router 1, it will always use this link. Similarly, on the router 2, I should see 24.4. So let's do verify the routing table here. Okay, it is here. 200 network is learned via 10.1.24.4, and also default route is learned via this. So we should be good with these two checks now. The failover scenario will check in a shortly. Okay, now we will verify inbound verification of inbound traffic. So we what we will do is we will jump onto router 3 and router 4 and verify how the traffic is coming. Inbound traffic means we are sending this traffic, right? From 11 and 12 we are sending the traffic to the service provider. So we will verify how we are learning that. So what we had done is we had configured AS path prepend, and as per AS path prepend we should see the routes. So let's go ahead and jump onto router 3. Show IP BGP is my command, and you can see that this 11.0.0.0 network, the next hop is 10.1.13.1. Okay, and similarly for the 12 network it is having so many prepended AS path. So if you want to if anyone wants to reach to this network, let's say if someone sitting here and if the packet is coming to this guy, okay, he will always use this path for 11 network and this path for 12 network, because let's verify here. Show IP BGP. See here, for 11 network he is not going to use this path because it has so many AS path prepended, right? For the 12 network it is the best. So IP route also you could do. For the 11 it is going to use 200.003. You could see that if you want to reach to 11 network, okay, it is going to send the traffic to 200.003. So I am here, okay, and if I want to reach this 11 network, it is going to send the traffic to 200.003, which is this IP address here, 200.003. Okay, and if you want to reach to 12 network, it is going to send the traffic to F0/0, which is if you want to send the traffic to 12 network, the next hop you could see that 24.2. 24.2 is nothing but this one. This is 24.2 here. Okay. Similarly, you can verify on router 3. Show IP route. On router 3, you could see that if you want to reach to 11 network, it is going to send the traffic to 11 13.1. If you want to reach to this primary network, it is going to send the traffic to 13.1, which is this. And if you want to reach to 12 network, it is going to send the traffic to this IP address 200.4. See 200.4. Okay. So this is about our inbound policy. Whatever we advertised using the AS path prepend, it's working perfectly. Okay. Now the next step is failover scenario. So when the link fails, what is going to happen? That we will verify. This is the final checks we will be doing. So we verified show IP BGP, show IP route. Now the failover test. R3 R1 link shut down at R3 site. Okay, let's say okay, let me take a snapshot again. I'm not good at drawings, so please bear with me. I'll take a screenshot again here. Okay, and now we are performing failover test. Okay, so the first failover check, what we our strategy is, if R1 R3 let's shut down this link. So what I'm doing here, I'm shutting down this link or this interface here. Okay, and what it tells that R1 should use R1 R3 link for internet. So this our router 1 is always using this link for internet. Okay, now this link itself is failing. Okay, so when this link fails, router 1, if any packet is coming to router 1, he should send that packet to router 2. Okay, so what we will do is we will shut down this interface and we will do the first check. Okay, we will shut down this interface and we should see that the BGP neighbor for this particular 200 network, it should tell that this is my next hop. Now for the 200 network, it should be showing this as the next hop. Okay, let's verify that. Let's jump onto router 1. Okay, and show IP route. If you do a show IP route for 200 network, currently router 3 is my next hop, which is this one, 13.1, 13.3. This is the next hop. Okay, so I will shut down this interface. So this should automatically divert the next hop to this iBGP neighbor, which is I believe 11.0.0.x. Okay, so let's go ahead and do that on router 3 fa0/0 conf interface fa0/0 shutdown. Okay, this should reflect our on router 1. We should see that this should change. If it is working, it will change. If not, then I don't know. It is still the same. I don't know what's happening. Let me clear the BGP neighbors once. Show IP BGP summary. The neighbors are not coming up. 11.0.0.2 has come up. This is my iBGP, whereas my eBGP should not come up because I have shut down this interface. My eBGP should not come up. I should have taken some time because of conversions. It would have automatically come. There is no need to clear the BGP neighbors. If you are dealing in a production network, you don't do this. Show IP BGP summary is done. Then show IP route. In the show IP route, I'm not seeing any route coming. Okay, now the 200 network is coming here. Okay, and you could see that earlier my next hop is 10.1.13.3. Now my next hop is this one, 11.0.0.2, which is coming from iBGP neighbor. See, 11.0.0.2. So this confirms my failure test when R1 R3 link fails. Okay, similarly I need to do one more verification. If one of these links fails, it should come back to second available link, which means that for the incoming traffic also, right? For the incoming traffic also, I have configured this as a primary link. For example, any traffic for 11.0.0.0 network is always going via this. Now this link is down. Okay, so if any packet is hitting to router 3, it should send the packet to router 4, and from this way it should come. Okay, so let's verify on router 3 what's happening. On router 3, if you check show IP BGP, or the easiest way is to check show IP route, it should show for the 11 network and 12 network. For both the networks, it should show 200.0.0.4. Okay, earlier what it was doing for the 11 network, it was showing this as the next hop, and for 12 network it was showing this as the next hop. Now for the 11 network also, it is showing this as the next hop. So we are good with the verification. So far everything is looking very good and perfect. So I will bring up the interface on router 3. no shut. It should take some conversions time, and then I should see the changes shortly for the 11 network. For the 11 network on the router 3, it should change to 10.1.13.1. So this next hop should change. Okay, there it is. For 11 network, it has changed to 10.1.13.1. Similarly, for the next check, for the second test, what I need to do is similarly R2 should, now the router 2 is taking for the outgoing traffic, it is always using this path. Okay, if you shut down this link, either this interface or this interface, it will perform the same thing. So so far we are good with this scenario, and I think we have tested most of the thing. If you want me to test the other part also, I can do that. Show IP interface brief. So what I will do is let's check show IP route first. Okay, if you do show IP route for the 12 network, it is showing 10.1.24.2. This is the primary link. For 11 network, it is showing for the 11 network, it is going via this way. Okay, so when I shut down this link for both 12 as well as 11, it should show this as the next hop, which is 200.0.0.3. Okay, you can see that. Next, for one thing, it is showing 200.0.0.3. For other thing, it is showing 10.1.24. Interface fa0/0 shutdown. I did a shutdown here. Show IP route, you could see. Okay, it has taken the effect immediately. Okay, so for 11 and 12, the traffic is going via this way because this interface is down. Let's say you have a user sitting here, and if by chance the traffic is coming here, he will send the traffic to router 3, and from router 3 it will go. Okay, now similarly on the router 2, if you want to reach the 200 network, what used to happen, if I have a computer here who is trying to reach to 200 network, the traffic used to come here. Okay, if it is hitting on router 2, it used to exit this way. But now as this link is down, the traffic should divert to router 1. So let's verify on router 2 what is happening. So see, earlier default route is coming via this way, that is 24.4. If the traffic comes here, he will definitely go over this interface. As this interface is down, it should change this behavior, and what I should see is the traffic should go via this link here, which is I believe 11.1.1.1. Not sure whether it's a convergence time. It is still not taking the effect. I may have to clear the BGP session. It would take some time, so I don't want to wait here. So I just cleared the neighbors so that I should see it this way. I'm still not receiving the route. The configurations look correct. Everything is correct. And I have received these 4 routes here now. It is showing that I have received the 4 prefixes, but it is not getting in there. It is showing the rip failure for some reason. Okay, it marked this as a best route here, and it is showing the next hop as 11.0.0.1. So I should see it here. Okay, So it is taking a convergence time. Now I can see that the default route and 200 network is pointed to 100,000. So this way we have accomplished this task, the complete network topology and complete setup, how the failover is working, and we have full redundant network. We have two routers at our side, and we have two routers at the ISP end, and we have full redundancy. If one link is going down, we are still able to reach via other link, and so on. So um, I hope this has been informative to you, and I want to thank you for watching this video. If you like this video, hit the like button and please subscribe my channel so that I can come up with more scenarios and more such topologies. Thanks a lot. Have a good day.